Hi, this is Stu Schwartz from MasterMathMentor.com. This is Super Free Response Practice AB question number 6. Super free response questions are similar to the typical free response questions in past AP exams. But instead of having the usual 3 or 4 subparts, these will have a great many more. It allows us to use the problem setup as a source of many inquiries that can be taken and allows us to do an in-depth study of the situation. Because of that, many calculus concepts are tested and some reiterated. Doing these will take more than the usual 15 minutes, but by tackling all subparts, you will know what topics you need to emphasize as you prepare for the AP exam. It is recommended that you go to the MasterMathMentor website and download the PDF with the actual problem and subparts. If you don't have a printer available, use a piece of paper for parts A, B, C, etc. This video will just show you the solutions, although you can fast forward at times to bypass the solutions and just show the problems. 6 reads, a patient is suffering from severe spinal stenosis, a narrowing of the spinal canal in the middle of the lumbar spine between the L3 and L4 vertebrae as shown below. A magnetic resonance image, an MRI, shows that the diameter of the spinal column at selected distances x in millimeters from L3 is given. It is assumed that this diameter d of x is a twice differentiable function as given in the table below. It is also assumed that the spinal canal is in one plane. We see the table and it is marked in distance from L3, x in millimeters, and it starts at 0 and goes up to 12, and then the diameter d of x also in millimeters. Notice in the picture that L3 is on top and L4 is on the bottom. So notice that our x measure, which is the distance from L3, is our vertical going down, and our diameter d of x is our horizontal going across. On a personal note, spinal lumbar stenosis is what I am going through right now, and believe me, it is not fun. But I'm enduring, and during this time I thought I would write a problem about it. Part A reads, use data from the table to find an approximation for d prime of 2. Show the computations that lead to your answer and indicate units of measure. There are 3 possible answers. D prime of 2 is approximately d of 4 minus d of 2 over 4 minus 2, giving 3.1 minus 3.5 over 2, or negative 0.2 millimeters per millimeter. Or d prime of 2 is approximately equal to d of 2 minus d of 0 over 2 minus 0, which is 3.5 minus 5.8 over 2, or negative 1.15 millimeters per millimeter. Or d prime of 2 is approximately equal to d of 4 minus d of 0 over 4 minus 0, which is 3.1 minus 5.8 over 4, which is negative 0.675 millimeters per millimeter. 2 points for this problem, 1 point for one of the difference quotients, and 1 point for the correct answer with correct units. Part B asks, write an integral expression in terms of d of x that represents the average radius in millimeters of the spinal canal between L3 and L4. This is an average value of a function problem, and therefore the answer is 1/12 the integral from 0 to 12 of dx over 2, dx. We divide by 2 because we're interested in the radius. And we can write this as 1/24 the integral from 0 to 12 of d of x dx. 2 points for this problem, 1 point for the limits and constant, and 1 point for the integrand. Part C reads, The answer to part B is to be approximated first with a right Riemann sum and then a midpoint Riemann sum, each with 3 subintervals of equal length. We want to find the difference in these calculations. We start with our right Riemann sum. We are interested in 1/12 the integral from 0 to 12 of dx over 2 dx. That will be approximately equal to 1/12 times. We have to talk about our base times our height. Our base is always 4, and the heights will be b of 4 over 2, because we're interested in the radius, plus b of 8 over 2, plus b of 12 over 2. This gives 1/12 times 4 times 1.55 plus 2 plus 2.25. This gives 23.2 over 12, or 1.933 millimeters. For midpoint Riemann sums, we are still approximating 1/12 the integral from 0 to 12 of dx over 2 dx, and that will be approximately 1/12. The base of each rectangle is still 4, but now the midpoints will use b of 2 over 2, b of 6 over 2, and b of 10 over 2. So we get 1/12 times 4 quantity 1.75 plus 1.75 plus 2.25, and that gives 23 over 12, or 1.917 millimeters, and the difference is 0.016 millimeters. For points, 1 point for the right Riemann sum setup and 1 point for the right Riemann sum answer. 1 point for the midpoint Riemann sum setup and 1 point for the midpoint Riemann sum answer and the difference. D reads, explain why there must be at least one value of k for k between 6 and 10, such that d prime of k is equal to 0.25. D is twice differentiable and therefore it is continuous. So the mean value theorem applies, and therefore d prime of k must equal 4.5 minus 3.5 over 4 minus 0, which is equal to 0.25, at some k on 610. 1 point for stating the conditions of the mean value theorem, and then 1 point for the explanation. E reads, explain why there must be at least one value x, where x is between 0 and 12, such that d double prime of x is equal to 0. This uses the mean value theorem twice. By the MVT, d prime of C1 has to equal 0 for some C1 on 2, 6. And d prime of C2 must also equal 0 for some C2 on 10, 12. So, because the function is twice differentiable, the mean value theorem applied to d prime of x will then state that d double prime of x has to equal 0 for some x on C1, C2. 3 points for this problem. 1 point for d prime of x equals 0 on 2, 6. 1 point for d prime of x is equal to 0 on 10, 12. And then 1 point for the explanation that d double prime of x has to equal 0 at some value on 0, 12. Part F reads, write an integral expression in terms of d of x that represents the volume in cubic millimeters of the spinal canal between L3 and L4. You can think of this as a volume of rotation problem where the axis is the center of the spinal canal, and we are interested in rotating the radius about that. The radius is d of x over 2, so v will equal pi integral from 0 to 12 of d of x over 2 squared dx. This is the disk method. 2 points for this problem, 1 point for the limits and constant, and 1 point for the integrand. The answer to part F is to be approximated with a left Riemann sum with 6 intervals of equal length. Find the value of this approximation and show how you arrive at your answer. Even though the Riemann sum technique uses rectangles, and we are interested in volume, the technique is still the same. We will now be adding up left Riemann cylinders. The volume of a cylinder is pi r squared h. We know the radius, and we know that since there are 6 subintervals, then each subinterval has height 2. So V can be represented as 2 pi times the sum of each radius squared. So we have 2.9 squared plus 1.75 squared plus 1.55 squared plus 1.75 squared plus 2 squared plus 2.25 squared, and we get an answer of 52 pi cubic millimeters. 3 points for this problem, 1 point for the formula, 1 point for the calculations, and 1 point for the answer. H reads, if k is between 0 and 12, write an expression that represents how fast the volume of the spinal canal between L3 and L4 is changing at x is equal to k. We start by writing the volume as pi integral from 0 to k of dx over 2 quantity squared dx. It could be 0 or any other constant. And now, since we would like to find out how fast that is changing, we look at dv dx, which is the integral of pi integral from 0 to k of dx over 2 quantity squared dx. And by the second fundamental theorem of calculus, we get pi times d of k over 2 quantity squared. Just 1 point is given, and that is getting the correct answer of this problem. I reads, it can be determined that the diameter of the spinal column between L3 and 2 millimeters short of L4 can be modeled by the function f of x equals 6 minus 2x e to the negative x over 4, where x and f of x are measured in millimeters. Find f prime of 2 and explain its meaning in the context of the problem situation. This involves the product rule, and we take f prime of x is negative 2 times x e to the negative x over 4 times negative 1/4 plus e to the negative x over 4. Plugging in 2, f prime of 2 is negative 2 times negative 1/4 times 2e to the negative 1/2 plus e to the negative 1/2. And this gives negative 1 over the square root of e. The interpretation is that the spinal canal's diameter is shrinking by 1 over the square root of e, millimeter per millimeter. 3 points for this problem, 1 point for finding f prime of x, 1 point for finding f prime of 2, 1 point for the correct units and its meaning. Part J reads, using f, find the narrowest distance between the walls of the spinal canal. Justify your answer. This is a max-min problem. We would like to minimize f, which is the distance between the walls. So we look at f prime of x, which is negative 2 quantity, negative 1/4 x e to the negative x over 4 plus e to the negative x over 4, and set that equal to 0. Doing some factoring, we get e to the x over 4 times the quantity x over 2 minus 2 is equal to 0, and that gives x is equal to 4. As a justification, we see that f prime of x is less than 0 if x is less than 4, f prime of x is greater than 0 at x is equal to 4, and therefore we have a minimum at x is equal to 4, and the canal is narrowest there. The diameter would be 6 minus 8 over e millimeters. Alternately, you could look at f of 0, which is 6, f of 4, which is 6 minus 8 over e, and f of 10, which is 6 minus 20 over e to the 2.5. Without a calculator, we see that 8 over e is greater than 2, but 20 over e to the 2.5 will be less than 1, and therefore the minimum is going to be 6 minus 8 over e. 4 points for this problem. 1 point for f prime of x is equal to 0, 1 point for x is equal to 4, 1 point for the justification of the minimum, and 1 point for finding the actual diameter. K reads, using f, find the value of x where the diameter of the spinal canal is growing the fastest, and justify your answer. In this problem, we are asked to find where the diameter is growing the fastest, which means that we are looking at the second derivative. We want the growth of the canal to be a maximum. So f double prime of x is negative 2 quantity 1/16 x e to the negative x over 4 minus 1/4 e to the negative x over 4 minus 1/4 e to the negative x over 4. We can factor out a e to the negative x over 4 times the quantity negative x over 8 plus 1, set that equal to 0, and x is equal to 8. Since the second derivative of x is positive if x is less than 8, and the second derivative of x is negative if x is greater than 8, there's an inflection point at x is equal to 8, and therefore the canal is growing the fastest at that value. 3 points for this problem. 1 point for setting f double prime of x is equal to 0, 1 point for the answer x is equal to 8, and again 1 point for the justification. L reads, using f, find the volume of the spinal canal between L3 and 2 millimeters short of L4. As we saw in part F, this is a volume of rotation problem where the radius is the function divided by 2. So v will equal pi integral from 0 to 10 of f of x over 2 quantity squared dx via the disk method. And that is equal to pi integral from 0 to 10 of 6 minus 2x e to the negative x over 4 over 2 quantity squared dx, and we can divide out by 2 to get pi integral from 0 to 10 of 3 minus x e to the negative x over 4 quantity squared dx. We cannot perform this integration, so we use the calculator and we get v to be 35.586 pi, or 111.797 cubic millimeters. 2 points for this problem, 1 point for the constant and limits, and 1 point for the integrand and answer. M reads, when the spinal canal is narrowing between L3 and L4, write an equation that finds the value k such that x equals k divides the volume of the spinal canal into 2 equal volumes. We saw in part J that our spinal canal was narrowing between x equals 0 and x is equal to 4 millimeters. So there are 2 possible answers we can use here. Pi integral from 0 to k of 3 minus x e to the negative x over 4 quantity squared dx is equal to pi integral from k to 4 of 3 minus x e to the negative x over 4 quantity squared dx. Or we could say 2 pi integral from 0 to k of 3 minus x e to the negative x over 4 quantity squared dx is equal to pi integral from 0 to 4 of 3 minus x e to the negative x over 4 quantity squared dx. Just 1 point here for one of the correct equations. N reads, greater detail is needed, and the MRI shows that for x between 10 and 12, the function that models the diameter of the spinal canal has first derivative given by d prime of x equals 8x minus 88 times cosine pi x. We would like to find d of 11. We use our formula that d of 11 is equal to d of 10 plus the integral from 10 to 11 of d prime of x dx. We know from our chart that at x is equal to 10 millimeters, our diameter is 4.5 millimeters. So we get 4.5 plus the integral from 10 to 11 of 8x minus 88 cosine pi x dx. Using our calculator, we get d of 11 is equal to 4.5 plus a negative 1.621, and we get 2.879 millimeters. 3 points for this problem: 1 point for adding the d of 10, 1 point for the correct integral and limits, and then 1 point for the final answer. Part O reads, for x between 10 and 12 is the answer to part N, the narrowest the spinal canal will be. If so, explain why, and if not, determine the narrowest diameter of the spinal canal. To do this, we look at a graph of d prime of x, shown in red, and we see that d prime of x is negative between 10 and 10.5, and then again at 11 to 11.5, and that means that d is decreasing from x running from 10 to 10.5 and 11 to 11.5. So that means that d will reach its narrowest at either 10.5 or x is equal to 11.5, as those values are the only possible locations where the accumulated negative area between the curve and the x-axis is at a maximum. So we look at d of 10.5, which is 4.5 plus the integral from 10 to 10.5 of d prime of x dx, and that is 4.5 plus the integral from 10 to 10.5 of 8x minus 88 cosine pi x dx. We just do the same thing for 11.5, and we get 4.5 plus the integral from 10 to 11.5 of d prime of x dx, or 4.5 plus the integral from 10 to 11.5 of 8x minus 88 cosine pi x dx. Both of those calculations, as we surmise by looking at the graph, are the same. So we get 4.5 minus 2.084, getting 2.416 millimeters. So that is the narrowest that the spinal canal will be. 3 points for this problem. 1 point for determining the values of x is equal to 10.5 and x is equal to 11.5. 1 point for explaining why the minimum occurs there, and then 1 point for the answer of 2.416 millimeters. As stated at the beginning, I am currently having pain and discomfort from spinal stenosis, and that's why I chose to write this problem. Shown are the original points in blue, showing the diameter of the spinal canal at x is equal to 0, 2, 4, 6, 8, 10, and 12 millimeters, and the model diameters shown in red. Note that our original assumption of differentiability clearly fails at x is equal to 10. That is where the spinal canal clearly narrows, perhaps because of some bone growth along the canal. Since nerves send electrical impulses to all parts of the body through the spinal canal, it is clear that they are being pinched, which is causing me pain and leg dysfunction. But I'm slowly recovering. It's nice to understand the source of our problems. There is a total of 40 points available for this problem. There is no exact formula for what number of points will constitute a 5, 4, 3, 2, or 1 on the AP exam. However, these percentages are what have been used in the past based upon exams released by the College Board. While you can extrapolate for just this question, realize that this question only tests a limited number of AP topics. So it is recommended that you do a number of the super free response questions in this series. Then combine your results, total your points, and then use these percentages to get a feel for how you will do in the AP exam. And more importantly, what concepts you need to strengthen in order to improve your score.